Alright guys, so welcome back to my YouTube channel. This is going to be the third video of the trial questions discussion in 2021. So we are going to learn still about functions, and we're going to review the different patterns of questions that you might see in this chapter of functions, which is Form 4 Chapter 1 in AdMaths. So I'm going to switch my method of presenting rather than the last two parts, which was via the whiteboard, but now I'm doing it through the tablet, and I'll be writing down the solutions for each trial questions on it. So hope you like the presentation. So do give this channel more support, like, share and subscribe, and also I've also introduced a TikTok channel to notify my people when I do uploads. So yeah, let's get into it. So the first state we are going to go to today is per list, as you can see. So here's the question, and this of course are all the compilation of 2021 questions. So first of all, they said that let's review the question one by one. So they said functions f, g and h are defined by all these fx, gx and hx. So go through them quickly: x squared plus 1, 2x minus 5 and 2 power x. So these equations don't really matter at this point until you look at the question one by one. So first of all, they said to solve the equation f(gx) equals g inverse 15. So they gave you a condition here. So this is the thing you should obey to when you are solving this question. So how we are going to solve is part A. So part A carries 3 marks. So there's few ways which you can approach this. You can do it directly, something like this. Let's say like you can just proceed from here and go down, or another way is you can do f(gx) first and find the answer, and do g inverse 15 and find the answer, and after that you make both of these answers equal to each other based on the equation here. So that's two ideas I can think of how to go this question. It's the same thing, but it's just you show how systematic you are. That's the different methods that they are implying here. So I'm going to choose this method. This is my preference, but nothing is right, nothing is wrong here. So let's see how we solve this question together. So first of all, I'm going to find my f(gx). So again, composite functions, you need to know how to do it. You need to do the g function first and then substitute it inside the f function, because the order of composite function is this comes first, this comes second. So f(gx) is equal to f. So what is your gx function? Based on the question earlier we saw is 2x minus 5, and you'll proceed f(gx) equals to, you'll substitute this into your f function. Of course, you make this as your object now for the f function. So f function was x squared plus 1. So the x will be substituted by 2x minus 5 squared plus 1. So after this should be your knowledge of expansion of quadratic. So if you're insecure on how to expand it, so you can directly do the simpler method of just doing the repeated multiplication format. But if you can see directly, you can do it directly as well to save this step over here. So you will get f(gx) is 4x squared minus 20x plus 25 plus 1. So it's going to be this over here. So you already got your f(gx). So you can put this as number 1, and then later I will say let 1 equals to 2, something like that. So that's my idea behind this question. So now I'm going to find g inverse. So we already know that, let me change color, our gx is equal to 2x minus 5. So again, it's revising your concept of inverse function, how to find it. always make this assumption: G inverse X is Y. As you know, I've explained on the arrow diagram how this thing comes about, where your X is your object, and you must expect that GY is your image after you shift. So you will get X is GY. So then you're going to substitute this X here with the Y over here. So that's why the equation on the right hand side on top will be expressed in terms of Y. And what's our goal here is to express this equation here, Y in terms of X. So that this Y, we can substitute it with G inverse X based on the assumption over here. So let's do a bit of shifting here and there. So you will get X plus 5 is 2Y. Y is X plus 5 over 2. So from there, I can conclude that, this is a conclusion I can make, G inverse X is X plus 5 over 2. And they already gave you a condition that where G inverse 15. So the 15 is going to be substituting your X in this case. So when X is 15, G inverse 15 will be 15 plus 5 over 2, which is 10. So that's how you do it. So you already have this info, so you can label this as equation 2. And I'll proceed up there. So from here I can say that let, I'll change color, this one, say let 1 equals to 2. So I will get 4x squared minus 20x plus 26 equals to 10. That's the two info we got from this understanding of composite functions and inverse functions. So from here, if you notice, right, you already have to click in your mind directly, this is going to be a quadratic form. So make sure you get to that ax squared plus bx plus c is 0, the general form. So this is a key of solution in most maths questions. So how we are going to solve this is, you can see that 4 is a common factor of all the a, b and c constants in this equation. So you can divide the whole equation by 4, you will get this, which is much simplified. So from here you can try, can you factorize it directly or not? So yes, you can. So you find the combination that can give you plus 4, which is 4 times 1 simply. And if you want to get minus here, so I'm going to add minus on both sides in order to get a positive 4 as well. So from here you're going to expect two answers. X minus 1 is 0, X minus 4 is 0, X is 1, or X is 4. So yeah, that's done. You can write a conclusion down there. X is 1, X is 4 as well. So yeah, this is how you solve the question. And also, yeah, they didn't say, whenever they say solve the equation, always means they want you to find the value of unknown. Unknown in this case, I mean variables. No? So they won't tell you find the values of x, they'll say solve or evaluate. Evaluate is another one. Maybe evaluate is about finding a value, not in the form of a variable. So yeah, so there's 3 marks here. So how we're going to get these 3 marks over here? So let's see. Part A has 3 marks. So the first mark is when you can show this part over here, you get your K1. This is because you show that you understand that you must substitute this g function into the f function over here. This is your composite function understanding. So that's why you get the K1 mark there. And the next one is when you can find your g inverse down here. So if you find your g inverse equals to 10, you get another K mark here. So you must show this part over here that you substitute your x value with 15, and you can get 10 as well. So that will earn you another mark. And of course, 1 mark will always go to the final answer. But in this case, there's 2 answers, so it's a bit tricky here. So the n mark is going to apply if you get both of these values correct only. Both must be correct. So they will check and see if one is correct, one is wrong, which is quite low chance, because if you get the equation correct and all the factorization and stuff, you should be getting both values correct, so that will give you your N1 mark. So in total here you get 3 marks for part A. So yeah, this is how you solve it. So let's move on to part B. So part B is a graph. So let's read the question over here. Okay, so it goes like this. By using the same axis, so I want you to take note of this. Same axis means you have to sketch on the same plane of the graph which they provide you later on. So they say sketch the graph y is hx. So this is the function they already gave you on top here. So we know that hx is 2 power x. So they want you to sketch this graph and the inverse of this function. So you need to find out what is the inverse from here. Then only you can show both of these graphs on the space they gave you. So you can investigate the relationship of a normal function and inverse function. So from here you recall what are the properties of an inverse function as compared to a normal function. So you will know that they are the reflection in the line y equals x, and the domain of the normal function will become the range of the inverse function. They are opposite to each other. So let's see over here, how can we solve this graph and sketch it out nicely. So I'm going to do my working down here. So always when you have a graph, you cannot run away from the fact that you must have your table of values as always to plot it out. So let us do the table of values for hx first, or you can call it y is 2 power x. So let's say you can try out with random values. So I have my x here and my y here. So preferably we will use y is hx because the axis given is y against x. So you can put your table values here as y. But if you say hx also, I don't think it's such a big matter as well. It's the same meaning only. So I'm going to plot random values. Let's say 0, 1, 2 and 3 for my x, and I investigate what is the value of y that corresponds to the object value based on this function over here. So I'll get these values here. So you just substitute and count from your calculator. You'll get these values. So you can already plot for hx, or you can also find out what is your h inverse. So again the same method, let h inverse x is y, x is hy, and now you're going to substitute as 2 power y. So you want to find your y. So this is where the interesting part comes. How are you going to find your y in terms of x? Because y is a power to the 2 here, you must remember. So this is where you need to learn your logarithm chapter to know how to find y in terms of x. So although they put this in functions, it's the first chapter before log, but after you go through the whole syllabus, they can test you on this already. So that's why you need to master your log chapter a lot. Quite a lot of equations involve you to do this step in a lot of chapters as well. So you're going to log 10 both sides. As you know, in maths, everything must be equal. If you log 10 one side, log 10 also has to be applied to the other side. Same like, if you want to say x is x, if I put x plus 1 here, means x also must plus 1 over here to be equal on both sides. So after you do this, you can automatically shift y down here based on the log rule you learn later in chapters 4 or form 4. So from here you will get y is log 10x over log 10 2. And from here, what can you conclude? You can therefore say that h inverse x will also be log 10x over log 10 2. So this is, you already found your inverse function over here already. And from here, you can already start to plot your graph, your table of values for this function. So let me do the table of values down here. So again, it's all about random testing and trying to find out what it matches to. So I'll put a few columns here. Here is x. You can call here as y also, because h inverse x also mean y in this case, based on the assumption earlier. So I'm going to put the same domain for my hx function. I use this domain. So this x value is what we call domain. Here is the codomain based on your functions basics. So the first video is there, so you can learn more about how to determine domains and codomains and range, all that. So from here, I'm going to substitute h inverse x as x as 0 first. So I'm going to see what values can I get from here. So whenever you do log 10 0, right, you're always going to get infinity relationship. So that's a known fact that you must obey to. So you can't plot this value in the graph. So let's say you suddenly do this and find out this. Don't worry, just put an infinity sign there, but you can't plot it only. So if you keep on trying, you can try with log 10 1, and you'll find out log 10 1 is 0. So that's a legit value you can plot on the graph. And then log 10 2, definitely you'll get 1, because log 10 2 over log 10 2 will cancel off each other. Log 10 3, I get 1.58 like that, or you can say 1.6 or so. So you can still estimate approximately where to plot on the graph. And it's just a sketch only, remember. So it doesn't mean it has to be accurate. You're not drawing on a graph paper where there's scales you need to obey to, like in your linear law. So now let's go to the graph. They gave you this graph. So first of all, I use black. Try to be accurate as possible with your points. I'll try to zoom in here to fit more scale values. So this might not be accurate because I'm doing it on a tablet, but if you do it on the real exam paper, it's surely going to be more accurate. So first of all, let's plot for y is hx. So we have the table of values when x is 0, y is 1. So we're going to plot over here. And then when x is 1, y is 2, you can plot over here. When x is 2, y is 4, you can plot somewhere here. And when x is 3, y is 8. So it's here. So how the graph is, don't draw a straight line, because you need to know this is an exponential form, because it's 2 power something. So exponential form, there's always a key shape of graph that you should know, which is increasing exponentially like this. So this is how your y equals hx graph is going to be. It's always good to label the equation of your graph to don't get confused with the two graphs that you're plotting. Okay, so next you're going to plot y is h inverse. So now you see the magic happening. Why I say they are a reflection of each other. So when you see, right, 0 is infinity, that you can't plot. When 1 is 0, when x is 1, y is 0, you can plot that. 2 and 1, you can plot that as well here. And when x is 3, y is 1.8. So 1.6, sorry. So it'll be somewhere here like this. And from here, you must not get cheated with the shape that's going up. You should draw something that is opposite like this. So you can see here, this line is the y equals to x. And you can see it's a reflection on each other. Means this distance and this distance should be equivalent to each other, any point on the graph. So that's why they are called a reflection. Log graph has a typical shape like this. It will curve like this when you have a log on your equation. So that's what log does to your graph shape. So yeah, this is how you sketch the whole thing out. Yeah, don't forget to label it as well. Y is h inverse x. This line is optional. If you want to show, you can, but it's not as emphasized in the marking scheme. So where your marks are coming from here, so let's see. I'll write over here. So there's 2 marks for this graph. So first mark, which is the process mark, process 1. So they want to see that your hx graph is plotted correctly. I wouldn't say plotted, I'll say sketched correctly, because it's not plotting actually. So this is the key thing here. hx must be sketched correctly. So if you do this correct, you get the P1 mark. And P2 is the inverse function graph sketched correctly. So that's your 2 marks basically. So finding your inverse function doesn't earn you a mark here. They just look at whether you can plot it correctly. But how to plot this depends whether you can find out the correct inverse function or not. So this mark depends on your inverse function. So if you get this wrong, then this automatically you will lose this mark. So if you don't, you will get 2 out of 2 for this graph. And total, this question will carry you 5 marks in paper 1. So yeah, that is your Perlis paper discussion. So that's paper 1 in the first question itself. So usually paper 1 first question will be few marks only, so nothing much. So yeah, this is the simple part of functions. So next, let's turn our attention to the next state. Let's go. Okay. So the next state we are going to here is Penang. So Penang also came up with a question in the paper 1 for functions. So let's analyze it. They gave you an arrow diagram here, function h, and this is the mapping they showed. So you can quickly identify here. Can you see this part occurring here? So from here you can analyze that it's a many to one relation. And if I ask you, is it a function or not? Yes. Answer is yes, because in function or not function, we care about the image. It must end, the relation must end with the word one, as you can see here. If it ends with many, it's not called a function already. So we just scan through a bit. So they say state the value of m. So now we are going to find the value of m under this function. So first of all, how we are going to find the value of m is we must deduce a pattern that is recurring in this function. So let's see over here, I will do it over here. So A1, so it only carries 1 mark. So first of all, you must notice the pattern that maps all the functions together. So you can see that -2 maps to 3 and 2 also maps to 3. So you can notice here that same value of object mapping to the same value of image. I'm not talking about the negative sign, let's say. So you must think what relationship can give you a same value of number that maps to this object. So you can directly think of the square function, because if you square a positive number, 2 square, you get 4, and a negative number square, you also get 4. And how to get to 3 is you just minus 1. Both applies this concept. And if you take a look at the next numbers also, 4 square, you minus 1, you get 15. 6 square, you minus 1, you get m. So this is the key here. So you can directly solve, m is 35. So only 1 mark, so you just need to show you get the right answer, you already get the mark. But ideally show all these working steps to show how you get this pattern that reaches you to this answer over here. So yeah, that's how you score 1 mark for this section. So let's move on to A2. So A2, they said using function notation. So I need you to recall, I always mention this word in my videos. So you see they already put a question to you over here. So function notation will always have something like this. This is how you write it. This is the general form. So you have to suit your specific function that maps, that satisfies this arrow diagram to this form over here. So how you do it is, you can notice the pattern already. So you just have to write the answer directly. As I showed earlier, x squared minus 1. So why I say hx, you take a look at the question, what function they used here. You can see it's h maps x to get hx. So that's why I use that back. So if you write this correctly, so you must show your colon, you must show your arrow and the correct equation, of course. So here you will get your N1 mark as well. So this will cost you 2 marks total in your part A question. So yeah, quite a simple question, but make sure you get all these infos correctly. So this answer on A2 actually depends if you can get your M value correctly, which shows you understand the pattern. So that's how you derive a function from patterns, by observing patterns. So yeah, this is how you solve it. And then next, let's look at part B. I'll go up there, let's read the question. So part B, they gave you a function f and a composite function of f squared. So you must be thinking already here, you have to involve your knowledge of composite functions. And then they say find the values of m and n. So whenever I see they ask you find two variables, right, you're always going to apply one method called by comparing both sides of the equation. And why I say so, because you can see here they gave you fx in the form of variables here, and f square x they gave you with constants 36 and 21. So you can expect that your f function, when you double it, you will get squared. This m will get squared and others will follow on. So that's how I can compare with the composite function. So that's the idea you should have as soon as you see this question. If you try many exercises, you will notice this pattern in the questions. So part B, this costs 3 marks. So I'll write down back. So always have this habit of copying back or transfer the info from the question. So this gives you a clearer idea how to approach it. And you know f square x is 36x minus 21. So I can continue from here. I'll split it to show I know that I'll tell the examiner I know what's happening here. Because remember your indices chapter, f1 times f1, you get f square, which is the composite function over here. So you're going to sub your f function here. Fx is mx plus n. Don't get shocked when you see so many variables like this. Is still solvable. That's why we apply the by comparison method. So this will in turn come your x now under the same function of f. So this is how you get your f square x. So m. So whenever you see the x in the function, you will substitute this whole thing inside the x, and then don't forget plus n at the back as well. Because why? This function at the back contains a plus n, so you need to obey, although you added a plus n here already. So to complete it, you must write this plus n, and then when you go down, you can do your expansion. So by now you should already master all these basic arts of expanding equations, factorizing it. This all taught in your lower form maths or modern maths. So yeah, it's very vital also to solve questions. So from here I can notice, right? Can you see this part and this part? Whatever part on the left hand side and the right hand side that has a variable x at the back can be compared, because the coefficient is this. This has the same values, it's just that they put a variable here to find back what's the value under the squared function. So this part, this whole chunk, will compare to the constant here, because this constant, you see there's no variable at the back. No variable. And you can see here also no variable. So from here I can tell the examiner something like this. I'll show it over here. By comparing, So by comparing both sides of the equation, I will get that m square x is 36x. So your m square will become 36 because you cancel both x. So from here, always another common mistake over here made by most students. You don't only get m is 6 when you do m square is 36. So the theory is here, you can expect two chances, just like I showed you in the arrow diagram. Two functions, negative 2 square can get 4, 2 square can also get 4. So now I'm reversing the process. Square root 4, what can I get? You should say 2 or negative 2 based on this over here. So same thing here, that's why I put two possibilities, 6 and negative 6. But here is where you need to read back the question. Do they want two values of m? You read. Here, a big condition they gave you over here. Take note, this one. They said m is greater than 0. So when you look back to your answers, can this be accepted? You should question yourself. So that's why I will put here rejected. Because based on the question, this cannot be accepted. In the mathematical way where you find it, you can get two m values, but to satisfy the question, you will conclude that m can only be 6. So you tell back the examiner, since m is greater than 0, therefore m is 6. So just to alert the examiner that you know what you're doing. So how to find your n now? So let's see. Okay, so for n we know that mn plus n is negative 21 based on the equation earlier. You can see from here. We compared this side to this side. So from here, you need to know that you can only put the m value that you chose earlier. If you put negative 6n, your answer of n is going to vary, which will give you the wrong answer already. So that's how important that condition is, they stated there. So you can just do a basic linear equation solving, you will get n is negative 3. So you can do a conclusion at the bottom if you want. Therefore, m is 6, n is negative 3. So yeah, this is how you solve it. So where are the marks again? So when you can do this part over here, you should get 1 mark because you show how you can expand this equation from the composite function of f square. And you, every term they are going to check whether it's the same or not, this whole equation to give you this mark over here. And then the next mark, of course, you have two values here. So in this case, you will get 2 marks for m value correct and also the n value correct, which leads you to a total of 3 marks in this question. So total Penang in paper 1 is 5 marks also, which came out in question 1. So question 1, normally we can see the pattern that it's going to be 5 over 5 marks. So yeah, this is how functions question come out in the exam. Always your first question normally. So yeah, this is how you solve it over here. So in this case, they're not so strict that both of these values must be correct for you to get 1 mark. So both of it, you can get 1 mark. So if this one wrong, let's say, you still get 4 over 5 mark. So this is the advantage of this type of questions. So let's go to the next one. So the next is also a Penang paper, but in this case, there's a twist to it because it came out in paper 2 as well. So you can see that functions not only come out paper 1, but also in the trials it came out in paper 2. Okay, so let's analyze it. Okay, so they said the diagram shows a graph of absolute functions. Okay, take note again, famous function. Whenever they say absolute function, means they're talking about modulus. As you can see here, this is what they mean by absolute function. They want to know the absolute value. If you learned in physics, in chapter 4, form 4, heat chapter, they will tell you something of like an absolute zero, which is your Kelvin to Celsius conversion thing in your heat chapter. So this is where the absolute function comes from. They want to know the absolute value, means they don't care about the negative sign over here, they neglect it, they just want the positives. So that's why they call it absolute zero as well, which is the negative 273 degrees Celsius or 0 Kelvin. This is what is known as absolute zero temperature. So yeah, this is just a briefing for you only about absolute functions. Let's get back to the question. Clear this out. Okay, so they say this is the function. They didn't give you any values here. A and B are constants, and they gave you a range of -3 is less than or equal to x, less than or equal to k. As you can see here, this is the domain. So let's read the question. They say find the values of A and B, and again you see they put a condition here, means you're going to expect that you're going to get two values of A and B. Again this condition pop up, that's why they need to give you a condition to just ask you to reject one A value and also reject one B value. So you only get one A value and one B in the end. So that's how you get your 2 marks. So how we're going to do this is, the 2 marks come from the A and B value correct only, but you still need to show your working nevertheless. So from here, how can you analyze the graph is, you can see two known coordinates here. So how to solve this is, you have two unknowns, so you must know your x and px value. So you can see this point I can take here, when x is -3, your p is 2. If I take this point q and 0, cannot, because I'm just adding more variables to this complex equation already, which is a and b. If I add some more q, then you cannot solve already. Let's say this point over here, k12. Can I do this? Cannot also, because when x is k, I'll add another 3 values already. So one point I can see from here is this one. Many students might not notice this, because it's not a common coordinate where they show all these arrows and stuff. So you can see here, this is also a point lying on this graph of function, which is 0, 4. Very vital point that you can form the simultaneous equation. So that's why whenever you have two variables, this concept is super important. It should come to your mind directly already, because you need this to solve equations with more than one variable. So first of all, let's see A. So you know this function px is modulus ax plus b. So let's say at the coordinate of -3, 2. So you must know which is your x, which is your px. So first of all, you know the form of coordinates is x coordinate first, then y coordinate. So this will directly be your x, this will be your y or px. So you can conclude 2 is a bracket -3 plus b. So you will get modulus -3a plus b is 2. And from here, if you realize, when you break the modulus sign, you cannot just write 2, you should write positive or -2, because modulus will neutralize all the negative values and will cause the number on the right hand side to take the positive and negative as well. So you need to consider that. So that's why we have two cases here. So -3a plus b can be 2, or -3a plus b can also be -2. So from here we are going to see which one are we going to proceed with. So this one we are going to put on standby first, because we have another equation, and remember the other equation has a 0 in it. You can see over here. So when you have a 0 here on the x function, it's going to eliminate the possibility of having the a value over here, because a times 0 you will get 0 already, and you only have one constant with a value of 4. So you can directly find your b value already, which can help you to substitute into the b values over here. So this is my thought process, how I go through. So then you can get two a values, and based on the condition, you reject one, you accept one. So that's how you get your answer. So let's work it out here. Let me see, I'll do it down over here. So next coordinate at 0, 4, you can copy down the function P0 is modulus A0 plus B, just to show that you know what's happening. So P0 will be B only, modulus B. So from here, you can also write a statement given that P0 is 4 based on the coordinates. So 4 is modulus B. So what is your B value? When you break the modulus, you can expect positive, negative 4. So from here, B can be 4 or B also can be negative 4. So this is when you have a conflict. You go back to the question. They want B to be a positive value. So this is where you have the power to decide what's your answer based on the question. So you can just write there rejected. Most cases, 85% I will say, negative you will reject. Because daily life situations mostly involve positive values only. Because most of the quantities are positive. Or in another way, I can say they are scalar quantities. They don't depend on direction, which gives you the negative value. So that is why we always reject negatives. And yeah, so that you can conclude that since B greater than 0, therefore B is 4. By saying this part over here itself tells you that you are aware of the question needs. So you are telling the examiner you notice that part of the question where they ask you to reject one value automatically. So yeah, so by using this B value is how you proceed. So you have the equation there. Here. So you have that negative 3a plus b can be 2, or negative 3a plus b can be negative 2. So you say when b is 4, because we found the value, so negative 3a plus 4 can be 2, or negative 3a plus 4 can be negative 2. So you find your a value. This side you will get a as 2 over 3. Be careful of your shifting. This side you will get a is 2. So you have two positive values here. Which one you're going to accept? Again, go back to the question. A, they want greater than 1. This is the condition over here. So how you satisfy it? You see the values. This is approximately 0.6667. But this is definitely greater than 1. So that's why we will reject this. And you can conclude, since a greater than 1, therefore a is 2. Done. So where's your marks? Your B value is correct. You will get 1 mark over here. And another B value is correct. You get 1 mark over here. So this gives you total of 2 marks for the part A question. So how to do part B? So part B is find the values of K and Q. So first of all, you need to know what is the K value representing and what is the Q value representing. So you need to know K and Q actually means the X value over here in this case. So if you want to see how to solve it, again you're going to rely on the function again. So we know that at Q0, you will know that PQ is equal to modulus 2Q plus 4. You substitute your X with Q over here. So you know that Q will respect to 0. So 0 is modulus 2Q plus 4. And simply you will have only one value because there's no positive or negative 0 here. So you will get Q as negative 2. So that's one value found already. So now how to find K? Again, use back the coordinate at K12. So you will get PK is modulus 2K plus 4. And you know K respect to 12. And now you're going to expect two values again because 12 you can have positive and negative. 2K plus 4 is 12 or 2K plus 4 is negative 12. So how to find your K here? 1K you will get is 4. Another K you get as negative 8. So who we're going to accept here is based on the diagram over here. That's why they gave you a diagram to indicate. You see K is located on the right side of x-axis, which is always positive again. So this tells me that I can put a reject on the negative value. And I can conclude since K greater than 0, therefore K is 8. Done. So this one 4 marks. So where is it coming from? So first of all, your first mark, you must show that the modulus function on top here for the Q value. Here you get your K1. And when you can find your Q is negative 2, you get your N1. And the next one is when you can show this function over here, another K1, and when you can get your K value is 8. Sorry, this one has to be rejected. K should be 4 because K is the positive value, so K is 4. This will give you the N1 mark. So total here is 4. So for part C, the last one, part C is only 1 mark, so it's just state the answer directly. They say state the range of Px corresponding to domain. So again here it depends on the diagram on top. So they say the domain is negative 3 to K. So you must see what is the value of Px when x is negative 3 and when x is K. So you can see here when x is K, the highest value the graph peaks to is 12. And when it's negative 3, the highest value it goes to is 2. So from there, 0. Because negative 3 and 0 is on the same coordinate as well. This is one coordinate and 4, 12 is another coordinate as well. So you can conclude that how to write range, you must write it in the correct manner as well. So range will be, so what function do I write here? Depends on the graph of the y-axis. So the y-axis use Px, you write Px here as well. So this is how you get your N1 mark. So total here in this question give you 7 marks. So it's more than the 5 mark because it's a paper 2 question. So yeah. So this is the first part of the third part of the discussion. So stay in tune for more discussions, upcoming ones for the later parts. So yeah, hope this content will be useful for all of you.